Okay, so when I first saw this problem, my original thought was not correct actually, but it was to um, sort the array by the ratio of the value to the weight, so that you'd have the highest value to weight ratio at the beginning, and then for each capacity, go through the list adding the first items until you hit capacity. But that does not work because in situations like the second example, you would get the 9 instead of 10 because it starts with the first ones, and in some situations, you wouldn't be able to fit the ones that would give the best value if you removed an earlier one. Because it has the better ratio, doesn't mean it's going to be the best answer because it doesn't always fill it to capacity. So where I went from there is where I should have gone from the beginning, which was it's then called dynamic programming, so using dynamic programming. So the idea is to make two maps, each of size W, each of size capacity, um, one of which stores the values for each weight, starting from 0 going up to capacity, and the second one stores the list of items which would get us to that value. So to start actually, and with that you can eventually, when you get to the capacity, you return item list entry up with key capacity, and that list will be the correct answer. So to start, we're gonna use Ruby, but we're gonna define max value with capacity and value, or not value, items. All right, so let's make those two hashes that I was talking about. So values is going to equal a new hash map. We're going to map the very first value to 0 because with a weight of 0, nothing can fit in. So it's always going to be 0. And similarly, the item list for 0 is always going to have nothing in it. All right. So now we're going to need some indices for what I'm about to do next. We're going to have an indice I, which is going to start at 1, and the indice j, which I need to declare a little for a second. So while I is less than or equal to capacity, so for basically for each value starting at 0, or 1, because we already have 0, going up to capacity, we're going to do what follows. The starting thing is declare a new index called j, which is always going to... Sorry, I think I lost video for a second there. Just gonna get it back. Something is wrong. Do not know what. Okay, we'll just use this. How about that? Sorry about that. Alright, where was I? I was talking about j, I think. But we're gonna start at 0 and we're gonna go to the next while loop. We're gonna be going through each item in items. So while j is less than items dot length, we're going to call something new called previous, which is going to equal I minus items j dot weight. So this value is going to be the current weight minus the current item's weight. So if this value is greater than or equal to 0, it means that I can fit in a bag with capacity I. So in that case, actually beforehand, this does not like using the then statement, so we're going to do it this way. So if prev is greater than or equal to 0, so we're going to have another if statement to see if this is the current one we want to actually add into the maps. So if is going to have two parts, so let's describe it one at a time. So if values prev, so if the entry for a value for the previous weight, the weight without the current item, plus items j dot value, so plus the value of the current item, is greater than values dot fetch I comma 0. So what that means is we're going to look through the map of values for the key I, and if it is there, you return the value corresponding to I. If it's not, you return 0. So basically this is saying that if the values of the previous plus the values of the current item are greater than the previous one, then we're going to do this. Or if there's nothing in the values for that weight already, then this of course is going to be greater than 0, so we're going to do it. So if this is the case, oh, we need a second thing. And we are not going to have, so if the item that we're currently on is not already in the items list for that previous weight. So item list prev dot include question mark j. So if the item list for the prev weight does not include j, then we can also continue. So in this case, we're going to store into values I, so the current current capacity. Going to get stored the values prev plus items j dot value. So just adding what the total value now would be, and add to the items list. I need values dot store. So value items list dot store with I as the key. The item list prev, so the previous item list, and then add to it the current in a array so we can add correctly. We're going to end that if statement and end the if statement before that. So now we're at the beginning of the second while loop, or the end of the second while loop, I should say. And we're going to increment j, and then end that while loop. So now we're at the end of the first while loop. So at this point, we've been through all the items j, and we need to deal with the situation of what happens if none of them fit that weight. So in that case, we need to say that if values.fetch I, 0 equals 0, so if there's nothing actually stored there, we get 0 back, then values.store I, 0 and item list dot store I, 0, that. Right. An important point is that this assumes that the values are all greater than 0, which is not explicitly given, but I think it makes sense to assume that in this situation. If the values could be 0 or negative, then we just have to change this to, if it could be 0, we change this to be less than or equal to 0 to give the situation. And if it could be negative, then we have to do a situation where we check for nil cases. But I'm not going to deal with that. I think it's fair to say that there are no negative or 0 values. So with that, we're going to end that if statement and then increment I plus equals 1. And that's it. That gets us to the end of the entire thing. Oh, no, we're not quite done yet, sorry. Of course, we need the very important return statement. Return item list capacity. So it returns the item list entry for the current capacity. And because it might be out of order to make it match the examples, we're going to sort it. We don't really need to do that, just makes it look better. And then end. Alright, so let's talk about runtime. So the first thing with the runtime is the key steps are the 2 while loops. So the first while loop, we have every value from 0, well, 1 technically, to capacity. So that's going to be complexity W. And then we're going to go through in the second while loop, we go through each item, which is complexity N. So a total of NW, which is what the goal is, because nothing in here, all we're doing is accessing a map, and that's constant time. So for space, our maps, we have 2 maps, each with the number of keys equal to W, so we are less than big O of NW space, which is always a good thing to be less. So let's go through a couple examples. Let's go through the second one, because that one's a bit more complex. So you're going to have items is going to equal the array containing the tuples, just 2, 4, so weight 2, value 4, 2, 5, and 5, 10. Alright, so the capacity is 5. Capacity equals 5. So let's make our values array hash, which is going to contain right now 0 points to 0, and close it up. And items list equals the a hash 0 yields the empty array. Alright, so let's go through it now. So for I equals 1, we're going to go through each one, and it's going to fail right here, because each one's going to be less than 0. The first two are going to be -1, next one's going to be -4. So we're going to end up putting in, we're going to go here, we're going to get 0 as the fetched value, which means we're going to store 0 in an empty array. So comma 1 yields 0, comma 1 yields empty array. Alright. So now for 2, we do get through this step now. So we go, it's equal to 0 exactly. So the previous value of 0 is 0, plus items j value is 4, and the fetched value is 0. And the previous does not include j, because the previous includes nothing. So we're going to store it into values. 2 yields 4. Then here, 2 is going to yield the array containing 0. Alright. However, we're not done yet. So we go back to the loop again, this time with j equals 1. And again, we're going to get 0 here. And this is where it's going to be different. The prev is going to be 0 still, but the value is going to be 5, which is greater than the 4 when we get fetched for I. And again, it's not included. So we're going to have to change the values we have in, and make it 2 is now going to point to 5, and in here 2 is going to point to 1. And 2 is still going to be too big, so we're not going to do it. We're not going to access it. So now 3, we're going to do the exact same thing, except this time we're going to have a remainder of 1, but nothing can fill that. So it's going to have the same exact situation where we start with 4 and then get 5, and 3 here is going to point again to 1. Alright, so now we get to 4, and this is where we get a bit more things. So when we go through, we got 4, we get previous is 2. So the values of the previous is 5. Plus the current item value of 0's item is 4, which is greater than 0, so we're going to put 9 in here. And then we're going to put in here, the previous value is still there, so that's 1, comma 0. Now we're going to go to 1, and 1 is similarly going to get through this up to here correctly, but it's going to fail here because it already is included. So we're not going to change it. We're not going to make 4 yield point to 10. 4 still points to 1, 0, and 9. Okay, so now 5 is the next interesting one. So when we get to 5, we're going to go through the exact same steps previously as the last as 4, where we get 2 of them pointing to 9. But when we get to the j equals 2, we're going to have previous equal to 0. So previous 0 is 0, and items j value, the value of 5 is 10, and that's greater than 9. So we're going to replace it and put 10 here, and replace the 0 and 1 with 2. So then we're finished because I is equal to capacity. So when we increment it at the end, it's going to be greater than, and we're going to stop, and we're going to turn items capacity, which is 2. And that's it. So that's all for this. Thanks. All right.